ASDIP CONCRETE was recently released with the addition of this new module for two-way slabs. It was based on the ACI code. Now the module includes a new code, the Canadian code CSA A23.3. This is Javier Encinas, and today we're going to review this module. It's an overview of this new feature in this module two-way slab, complying with CSA A23.3. Let's get started. When you open ASDIP CONCRETE, you see the project manager. Here you can see the modules included in the package: concrete column, concrete beam, concrete or masonry bearing wall, one-way slab, concrete shear wall, and now two-way slabs. I have prepared an example of a two-way slab complying with CSA A23.3. Let's open this example, double-click on this node. And this is the template of the two-way slab module in ASDIP CONCRETE. In this module, you can model two-way slabs, beam supported, as shown here, or can be flat plate, just supported on the columns, flat plate with edge beams, or a flat plate supported at the edge on a wall. If we go to the design criteria, which is either design criteria, or we can go directly to this icon. Here we can see the codes supported by this module. As you can see, the CSA A23.3-19 has been added to this list, both in the concrete design list and also in the load combinations. In this case, we are selecting CSA in both concrete and load combinations as an example of this new feature in ASDIP CONCRETE. Let's go to the Detail tab to see how this affects the calculations. As you can see, now the references of the code shows CSA all over the place. In addition, I have selected SI units, since these units are common in Canada. The program checks the direct design method limitations. In this case, is complying with these limitations, so we can use the module without any problem. Then the material properties according to the CSA code. Then the program checks the slab thickness according to the CSA provisions. If we selected flat plate, for example, then we need to check, in addition to the slab thickness, we need to check the punching shear. Since in this example is a beam supported slab, we don't have a punching shear problem, so we don't check that. Then the program calculates the bending moments in X direction for both column strip and middle strip, and the same in the Y direction, column strip and middle strip. Then the program checks the reinforcement based again in CSA. And here is the check of the reinforcement in the Y direction. Then the program performs the design in bending for the beams in the X direction. And here is the shear design of the X beams. Here the same bending design and shear design in Y direction. And finally, the program shows the design codes. If we go to the Condensed tab, we can see the results in a tabular form. It's a condensed format. Here we can see the bending moments in the X strip is divided by column strip and middle strip, and then the column strip is in turn divided in beam and slab portion. The same applies for the slab in the Y direction. Here is the reinforcement design for the slab in the X direction. And here is the reinforcement design for the slab in the Y direction. The beam bending design X direction, shear design in X and in Y. Finally, we go to the At a Glance tab. This is just a summary of the results in one screen, where we can see just at a glance if anything is failing. In this case, there are several issues here that we should attend. If we go to the Graph tab, the program generates the framing plan with the rebars that we just designed with the lengths in column strip, middle strip, in both directions. If we go to the slab elevation, the program shows the slab elevations in X direction and Y direction for column strip and middle strip, showing all the rebars and extensions. And if we go to the beam elevations tab, the program shows the beam elevation X and in Y, showing all the rebars, stirrups, and all the information necessary to prepare the structural drawings. If we go to the input side, Materials tab, here you specify the different stress-strain relationship for concrete and steel, and then in Loads, you define the applied loads. In this case, in addition to the self-weight, we are specifying some uniform dead and live loads. And here in Reinforcement, there are several visual controls designed to simplify the input of the reinforcement. So everything can be defined here, and the program will check the adequacy of the selection according to the code. Please note that we can select another code just with a click of a mouse. For example, if you want to design this per ASCI 318.19 and according to the ASDIP 722 load combinations, we just do this, click OK, and now the program complies with that code. The same applies for the units. Here we can select either US units, SI units, or MKS units. As you can see, the Canadian code CSA A23.3-19 has been implemented already in ASDIP Concrete. It's very easy to use. Just select in design criteria the corresponding code that you are interested in, and the program will perform the calculations accordingly. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.